Let us discuss about the order of a chemical reaction. Order of a chemical reaction. Now suppose you are given this reaction, A moles of A plus B moles of B gives M moles of M plus N moles of N. As we know, rate of chemical reaction depends on the concentration of the reactants. So we write the rate of chemical reaction as this, that rate of reaction is directly proportional to the concentration of the reactant A raised to the power X and B raised to the power Y, where X and Y are experimentally determined numbers may or may not be equal to the stoichiometric coefficients. May or may not be equals to the stoichiometric coefficients. And this proportionality constant is called K. So rate is equal to K into A raised to power X and B raised to power Y. Now this is called rate law. This is called rate expression. And this rate can be any rate. Can be any rate means it can be instantaneous rate of disappearance of A, it can be the instantaneous rate of disappearance of B, it can be instantaneous rate of formation of M or instantaneous rate of formation of N. So we can also write the rate law as this, that rate is equal to minus 1 by A dA by dt is equal to minus 1 by B dB upon dt is equal to plus 1 by M dM by dt is equal to plus 1 by N dN by dt is equal to K into A raised to power X and B raised to power Y. Now this is also known as, or this is also called, the differential rate equation. Differential rate equation. In simplified form we write rate is equal to K into A raised to power X and B raised to power Y. And the rate expression can be defined as, rate expression is defined as the expression relating the rate of chemical reaction with the concentration of the reactants each raised to the power equals to some experimentally determined numbers. And in this rate expression, A raised to power X, it means that A term is repeating X times. We have X number of A concentration terms on which the rate of reaction depends. And similarly, when we write b raised to power y, it means b term is repeating y times. It means we have y number of b terms on which the rate of reaction depends. It means in the expression rate is equal to k into a raised to power x b raised to power y. Rate depends on a total of x plus y concentration terms. So the total number of concentration terms, on which the rate of reaction depends, is called the order of chemical reaction. Now if you look at the equation again, that rate is equal to k into a raised to power x b raised to power y. Now this x is the exponent of a and y is the exponent of b. So order can also be defined as the sum of the exponents to which each concentration term is raised in the experimentally derived rate equation or rate expression. So in this case, x is the order of reaction with respect to A and y is the order of reaction with respect to B. And the overall order of the reaction is equal to x plus y. Next point, this order is an experimental quantity. And order can have any type of value. Now, any type of value means order can be 1, 2, 3, means can have integral values. But order can also be in fraction, or order can also be 0. So order can have any type of value. Now in the expression, rate is equal to k into a raised to power x and b raised to power y. This k stands for the rate constant. And this rate constant is defined as the rate of a chemical reaction when the concentration of each reactant in the rate expression is taken as 1 mole per liter. Now in this case the K is equal to rate upon A raised to power x and B raised to power y. Now in this case the total number of concentration terms equals to x plus y, so we can also write this way, concentration raised to power x plus y, and this is equal to rate upon concentration raised to power n, where n stands for the overall order of chemical reaction. Now we can derive the units for K, and the units of K, it depends on the order of chemical reaction. Order of chemical reaction. And for nth order reaction, the units of K equals to, rate has a units of concentration per time, and this is concentration raised to power n. So the units of K equals to concentration raised to power 1 minus n time inverse. And for zero order reaction, now when we say zero order reaction, it means n equals to 0, then the K will have the same units as rate of chemical reaction. And for first order reaction, n equals to 1, the K will have a units of only time inverse. It is independent of the concentration of the reactants. Now for second order reaction, n equals to 2, we can write the units of K equals to concentration raised to power minus 1 and the time minus 1. So if we know the order of a chemical reaction, we can derive the units of K. Now we have some examples now. Suppose you are given this reaction, twice of NO2 gas plus the Cl2 gas, it gives twice of NO2Cl and has a rate equation equals to R equals to K into NO2 and Cl2. Now in this case, the order of reaction with respect to NO2 is equal to 1, and the order of reaction with respect to Cl2 also equals to 1, and the overall order of the reaction is equal to 2. Now next example is this. Now suppose you are given this CH3CHO, this is ethanol, it decomposed to give CO gas plus the CH4 gas. And in this case, we express the rate of chemical reaction as a decrease in the pressure of the reactant CH3CHO. So this is our instantaneous rate of reaction in terms of the decrease in pressure of the ethanol. And this is equal to K into pressure of ethanol raised to the power 3 by 2. At constant temperature, concentration and the pressure, they are directly related. This is the concentration and is directly related to the pressure. So in this case, if you want to calculate the units of the rate and the rate constant, if pressure is given in bar and the time in minutes. Now in this case, the overall order of the reaction is three by two. So we write first the units for the rate of chemical reaction. Rate is defined as change in pressure of the reactant CH3CHO upon time. Now pressure is in bar and the time is in minutes, so it has units of bar per minute. Now units of rate constant, it depends on the order of a chemical reaction, and at a constant temperature, concentration and the pressure, they are directly related. So we write the K expression as pressure raised to power 1 minus n and time inverse. Now pressure is given in bar, raised to power 1 minus 3 by 2, overall order was 3 by 2, time given in minutes, so minute inverse. So rate constant has the units of bar raised to the power minus 1 by 2, minute inverse. So rate constant has the units of bar raised to power minus 1 by 2 and minute inverse. Now next, if the value of the rate constant is given, we can also calculate the overall order of a chemical reaction. For example, this reaction given A plus 2B gives C. Now this reaction has a rate constant at a given temperature equals to 1.36 into 10 raised to power minus 2 liter square mole minus 2 and second inverse. Now question is, what is the overall order of chemical reaction? Now in this case, the K has a units of liter square mole minus 2 and second inverse, and we express this as moles per liter raised to power minus 2 second inverse, and we equate this units with a general expression as this: moles per liter raised to power minus 2 second inverse is equal to concentration raised to power 1 minus n and time inverse. So this time inverse gets cancelled, and since the base is same, you compare the exponents. Minus 2 is equal to 1 minus n and n equals to 3. So the overall order of the reaction is equal to 3, but we don't know what is the order of the reaction with respect to A or order of the reaction with respect to B. We only know that overall order of the reaction is 3. Now we can take one more question. Suppose this reaction given A plus 2B gives C, and this reaction has a rate of reaction equals to 6 into 10 raised to power minus 3 moles per liter and per second, and the rate constant for this reaction is equal to 2 into 10 raised to power minus 2 second inverse. Now question is, calculate the overall order of the reaction when concentration of A is equal to concentration of B equals to 0.3 moles per liter. Now we write the rate equation as this, that R is equal to K into A raised to power X and B raised to power Y. And since A concentration is equal to B, we can also write K into A raised to power X plus Y. And this is equal to K into 0.3 raised to power X plus Y, which is the overall order of a chemical reaction. Now in this case, the R is equal to 6 into 10 raised to power minus 3 is equal to 2 into 10 raised to power minus 2 into 0.3 raised to power X plus Y. So this is 3 into 10 raised to power minus 1 is equal to 0.3 raised to power X plus Y, and this is equal to 0.3. Now again, the base is same, you compare the exponents, it means the overall order of the reaction X plus Y is equal to 1. So this is the first order reaction, but we don't know what is the order of the reaction with respect to A or with respect to B. So this is about the order of a chemical reaction.